the homework is from the Pigeonhole Principle. Number 9 was, what's the minimum number of students, each of whom comes from one of the 50 states? So we assume there are 50 states that they come from, who must be enrolled in a university to guarantee that there are at least 100 who come from the same state. Okay, so as always, we have our formula. Let me write it up here, our generalized Pigeonhole Principle. Okay, so you take the ceiling of this fraction, and that's m. So n is the number. So we always analyze this. What are our pigeons? What are our holes? And what is the minimum? We call this minimum. It's a bit vague what I mean here, but it's kind of clear always whenever we're dealing with these problems. Okay, so what are the pigeons here? So well, I'm not to be insulting, but the pigeons are the students. Okay, so the students here are the pigeons. And where do they go? Well, we are categorizing them by states. So the states are the holes. And what's the minimum here? Well, we need at least 100. Okay, so m is 100. Sometimes we need to calculate the minimum, sometimes we know what the minimum is and we need to calculate either n or k. Okay, so in this case, let's see, do we know what n is? No, that's actually the question. The number of states, yes, we know it's 50, and the number of minimum that we just said is 100. Okay, so now remember this formula means the same if you want to calculate n. You can calculate n from this formula as you take, what you do is 1 less than the desired minimum. Okay, so if you take that one, n minus 1, multiply it with the number of, with the number of holes, that's this number, that's just not enough. So you add 1 to it. Okay, that's how you find the optimal number. Okay, but of course you can say n a million and you're sure, right? If you take 1 million students, for sure 100 of them will be from the same state. But we want an optimal number. Okay, what's the best n that we can choose? Okay, so that's the question here, and so let's fill it out now, right? So we have 50 times 99, 100 minus 1 plus 1. So that is 4,550 plus 1, that is 4,551. So that's the number of students we need to guarantee that at least 100 come from the same state. Okay, number 35, I think, yes. There are 38 different time periods during which classes at the university can be scheduled. Okay, say 7 slots in Monday, 7 slots on Tuesday, etc. Perhaps less slots on Friday or something. In total, there are whatever, 38. Okay, and there are 615 different classes. So how many rooms do they need? Okay, so let's see. We ask again, what are the pigeons? Let me write this out in full. So what are the pigeons, what are the holes, and what is the minimum that we want? So what are the pigeons here? Let's think about it. Well, these are the courses, the classes, okay? We are scheduling them. Where are we trying to schedule them? Well, we're trying to schedule them in rooms, so the holes, or the rooms. Oh, sorry, no, I read the question wrong. If there are 607 different classes, how many different rooms will be needed? So the minimum are the rooms. So that's not the holes. The holes are, of course, the time periods, time slots. Okay. So what do we know here? N, the number of classes, we know it's given 677. What is the number of time slots? Well, we have to put these in 38 different time slots. Okay, and now the question is, right, how many rooms do we need? And that is m. So that is a number that we don't know, and that can be calculated directly now, since m is so this. So you see this formula. If it's in this form, gives us m. In this form, it gives us n. There's also sometimes a question when you how to find k, and I will do this in the review of the next quiz. But let's now focus on this case, so we can fill everything in. It's 677 divided by 38, and then we have to take the ceiling of this. So let me do this. 677 divided by 38, and that is 17.8. So if I take the ceiling of that, that is 18. So it's what it says is following. If I would only have 17 rooms, okay, then each room can be used 38 times a week, because there are 38 time slots. So we would have 38 times 18. Sorry, did I make a mistake here? Sorry, 17. Sorry, I misspoke. Sorry. What I'm trying to say is I want to check whether my answer is correct. 18. And so what I'm saying is, suppose it would be I would only have 70 rooms. 17. Would that work? Well, if I would have 17 rooms and I have 38 time slots, so every room can be used 38 times. How many different courses can I schedule? Well, that would be 17 times 38, which is 646. That's not enough because we need 677. Okay, so what I'm trying to say is that once you find a solution, I would really suggest take 1 minute time to see, is this now what I want it to be? Okay, so you see the problem with this type of pigeonhole principle is to determine exactly what is what. Okay, and so in this particular case, you might have been tempted to think that the holes were the rooms, but yeah, so you have to be you have to think properly about this.